Hi there. The purpose of this video is to show how to design a circuit board from concept to PCB manufacturing. The steps are: you define the project, you set up the project files, you design the schematic, you lay out the PCB, and you do the documentation by generating output files, and then you check what you did. First step is to define the project. It's what it is you want the circuit board to do. In this case, we have an I2C interface going between a master and a target, and we want to monitor the commands going between them. To do so, we will use a breakout board where we can connect the signals to monitoring equipment. Here's a block diagram of our breakout board. Next is to define what are the deliverables. We want to do a schematic and Gerbers and fab drawing, but there are other things that we could produce as well if we desired to. Next, we want to set up the project files. Okay, now we want to set up our project files. We go to Windows Explorer and we make a file that we want to put our project into. We open up Altium Designer, do New Project, and we change the name to Breakout. Do a Save As. Then we want to add the schematic by opening up the project panel and do Add New to Project. We also want to generate a new PCB, so we add New to Project, PCB. Then we want to make sure that we save those as the breakout, because we want them all to have the same root name. So there you go, we've set up the schematic and the PCB files. Now we're going to go ahead and generate our schematic. You select the schematic tab from the top of the window, and now we want to place some parts. In this case, we're going to place a header 5x2. I often like to change the grid to 100. You can do that by typing G and then selecting 100 grid space. It makes the schematic line up a lot better. Go ahead and place the part, and then we can add some wires. You can do that by selecting the Place Wire command, or you can select wires from the Quick Access toolbar. Okay, we can select the wire and then do Control-C, Control-V to make more wires. Sometimes that's easier because it gets them all the same length. Going to go ahead and do one side. And now we're going to select all of those on one side, Control-C, Control-V, and put them on the other. Now we want to add signal names to our wires. Place net label. In this case, it's already selected for us, but if you ever wanted to change it, you hit the Tab key, and you can change it there. I updated all the net names offline. All these connectors have the same connections, so we can simplify our schematic capture by just doing Control-C, Control-V. You'll next notice that all of the reference designators have a P question mark. We will use the annotation tool to fix that problem. Going to go ahead and annotate the schematic, and when we are done, we are going to see that all of the reference designators are as we want them to be. And there we have it. This concludes the schematic capture portion of this video. Now we're going to move on to development of the PCB. For this, we go to the PCB tab on the top of this page. We set our grid to 100, or something that's really coarse so it's easy to do placement that lines up nice. We're going to import changes. Notice that you see the parts over to the lower right hand side of the board. They're in what Altium refers to as a room, and we can click on the room and drag it onto the PCB. Next, we want to set the origin to the lower right hand corner of the PCB because it makes our measurements so much easier to do later on. Now you notice that the PCB is way too big for what we want, so we're going to resize it. If you hit 1, you go to the PCB edit command. Then we select the command for changing or editing the PCB size. We click on the edges of the PCB and we drag it in to a more acceptable shape. Now we're going to place mounting holes. It's always a good idea to do this early in your layout, because once you've routed the board and you need to add a mounting hole later, it gets to be a real pain to have to redirect already routed traces around the mounting hole. Now, arrange the components into a more aesthetically pleasing arrangement. This might take a little while. Now that we're happy with where things are, it's always a good idea to do your power planes early in the design, because you want to know where those are if you don't want to route over plane breaks and other considerations. So I'm going to set the grid to 25 because that makes it a little bit easier to do the power plane. And now just sit back and relax, because it takes a little while to navigate through all of the power plane considerations. Once we get the plane defined, you can use the Tab key and edit the parameters for the power plane. Okay, want it on the top layer, and we're going to connect it to a net, so we have to connect it to 5 volts. And we add the power plane, and you hit escape a couple times. Now with our 5 volts connected on the top layer using a polygon pour, we're going to connect the ground on the bottom layer using a polygon pour. To do this, we're going to use a different method by going through the polygon manager and creating a polygon from the board outline. Next, we assign the polygon to the bottom layer and give it the name ground. And we name the polygon. Then we apply the changes, and you'll see that there is a new polygon on the bottom layer called ground. Now we'll look at both layers and we'll see that 5 volts and ground is connected. Okay, with the planes out of the way, we can go ahead and route the board. I'm going to use active route because routing each one individually will take too long for the course of this video. Go ahead and select active route, invoke the command, and see what we end up with. That looks pretty good, so we're just going to go with this. If this wasn't such a simple project, it would have been prudent to adjust the layer stack before we did any routing, just in case we have any defined impedances. You open up the Layer Stack Manager and you check to make sure that the layer stack makes sense. We can look at it in 3D view and verify that the layer stack looks pretty decent. Okay, now that we've confirmed that our layout is acceptable, we're going to do some documentation. To do this, we're going to go to the Projects panel, add New to Project, and we're going to add a Draftsman. This brings up the Draftsman page, and we're going to place some items that we think that we should document. And place them in an aesthetically pleasing position on the document. Here comes the bill of materials. Now we're going to add the layer stack up. Notice that this is in millimeters. That might not be what we want. Okay, now we're going to change the unit of measurements. We're going to open up the Properties panel and change to inches. We're doing that since we're in the United States and we like inches here. Next thing we're going to do is add the drill drawing. PCB manufacturers normally use the layer stack up and the drill table to determine how much they want to charge to do the. Now that we've made the Draftsman document, we're going to go ahead and finish our final documentation. We can just go to File and select the different file outputs, but Altium has a more graceful method called the Out Job. So we're going to go to Projects, Add New to Project, Add New Out Job. You open up the Out Job window. You'll see on the right side there are output containers, and on the left side there are outputs. The goal here is to figure out what outputs you want and then decide which container you want to put them in. You'll see here that we're generating Gerber information. And then you have to configure the Gerbers to decide which layers do you want to output. You could generate a lot of different CAD documents, including a step file if you desire. And it's always good to print out a schematic as well. Now we click on PDF, because that's going to be one of our output containers, and then we're going to select which files we want to put into that container. Now we selected the folder outputs, and we're going to select which files we want to put into individual folders. You can see that we've gone and generated the output files by selecting Generate Output. Thank you very much for watching, and if you are in need of engineering services, please check out my webpage, SchottEngineering.com.